the one framework. So choosing the frameworks like in a LangGraph or like in a CrewA, Agentic AI, and before that we are trying to understand the LangChain as well. So in terms of the LangChain, so we have like what importance of the LangChain, and looking into the deployment perspective of the cloud sources like in AWS, the cloud and Azure cloud services, along with the what type. So in terms of large language models like in a, so what could be the ideal the services which we generally use like in a AWS Bedrock services or Azure EA Studio. So these are the kind of like an interesting the topics which we have covered in the last session. So from today we are the focusing on the agentic AI based the approaches like in a, so where we are trying to choose the one of the framework like an LangGraph. So in terms of LangGraph, where we are going to work on the two different use cases for the insurance industry, and another one is for the healthcare pharmacovigilance industry. So we are going to use the LangGraph framework, and on top of that, we are going to build the. We are going to learn how to apply the tools and how to apply the React agent, how to automate the end-to-end the flow system. So these are the kind of some interesting things which we are going to today, which we are going to discuss today, and we are going to implement the hands-on session as well.
Yeah.
Okay.
So I think we can proceed with today's agenda, Master. Yeah.
Yeah. Just okay. So just quickly jumping to the session. So, as I mentioned, like in the last week, we are going to do the more hands-on exercise for this boot camp. Along with that, we are going to see the live projects, okay, which we are implemented for the pharmacovigilance industry, and we are going to see the real-time data set information for this project as well. So to be before we jumping into the projects, like let's we understand what is LangGraph. So and in terms of like we'll try to understand what is agentic AI system, why it's so popular in terms of like many of the industries looking into the they wanted to bring this solution into their platform, so where it can be where it can be process of the speed of the existing process, and where we can save the lots of the money and lots of the time as well. So there are like various approaches to implementing this solution. So considering if there is in a companies they are running the customer support, so in order to running the customer support, there is a the plenty of team which is required, who are like associates, where they will receive the calls and they will do the non-voicing system, or they wanted to address the some of the challenge to particular the customers or the product. Now in terms of that, like the each and every complaint will be the similar about their product details itself, like in a way they wanted to verify, where they wanted to understand the customer query, and the based on the existing policies or existing the use approaches, where the associate will be helpful, associates are going to helpful to the customers. Now think about that, this all the processes like it's kind of the step by step the sequence process. So if you wanted to make the entire system should be automated, like it's not like consider it's not like thinking about the robotic process automations. So it's about like an AI agentic based approach, where the system can decide like okay, so this particular customer, so what could be the claim of, amount we can be approved. So like as a human agent will verify that, like based on these disease, based on these geographical locations, so if the patient applied for the claim approval, so the based on the policy, the advantages and everything, the policy, the duration, and the policy, like the some insured, by considering all the different the existing the futures, then they will be going to approve the claim. So this is something which we are going to, how we are going to automate it, like in how we are going to take up the decision. So this is where the agentic AI, the functionality which is came into the industry, where it is helping many of the industry to take up the decisions should be automated. So instead of doing the regular steps or the manual steps which they wanted to perform into the automated process, which can be like in the human level thinking of the automation process, like in a similar, like in how human will decide this based on this particular query what to be responded. Similarly, we are trying to respond for the multiple queries in terms of uh, various issues. We are going to respond into the agentic based as in a bot system level, bot based approaches in order to implement this solution. So in order to implement any system which we wanted to automate, so here is a picture came as an auto agentic AI platform, so which can be done with the various frameworks like an a LangGraph and the CrewEye and the AutoGen. So today's session, we are going to focus more onto the LangGraph. So what type of the features we have inside the LangGraph. So how do we integrate the various tools, and before we integrating the tools, like what are the tools which can be added to here in terms of that. So like implementation of the database or as an one tool, or like connecting to the as an API as a REST API as a or the another tool, and like connecting to the service now as a platform, or connecting to the Snowflake as a one platform. So connecting to the external services, like in how you are going to connect this external tool. So how you are going to decide, like based on this particular question, I supposed to be connected to these particular service, like in as a service now or Snowflake, I need to be connected. So all steps it can be decided by the the agent. So that's what the React agent we can call here. So in terms of all these steps which can be implemented with the LangGraph itself. So our entire session, we are going to cover up for any type of use cases, like in terms of if we wanted to develop agentic AI systems with the help of for the healthcare industry or the finance industry, or the HR based the use cases queries. So in terms of any organization level, the LangGraph is the ideal frameworks majority of the companies they utilized, because of their they have their the more advantage compared to the other frameworks, compared to the other frameworks like in a CrewEye or AutoGen, where LangGraph have a more advanced the features, and where you can have a customized the tool building and customize the functions where you can be implement everything. So that's why many of the industry they prefer to go with the LangGraph for to implementing the agentic AI based use cases. So in terms of why we are focusing for the LangGraph, so as I mentioned, it is for the entire structure. It is follow with the graph based approach, where each graph will be connected with the different tools or the nodes we can call. So each node will have specific actions, consider you are working for the team. So in a team there are multiple developers will be available. There will be the database engineer, database developer, or there's a front end engineer, there's a back end engineer. Each and every role will have the crucial in order to develop the applications in a organization, right? So these all the engineers will be connected to the team leader or the product manager. So similarly, when we are calling as an engineers in the regularly, so in terms of in the LangGraph we call as a node. So each node will be connected to the one agent. So here the agent will be the front end, or agent will be the back end, or agent will be the database developer, or agent will be the scrum master, or agent will be the team leader. So in terms of like an each and every agent, so we have to find out the agent where it can be identified that okay, for this particular the use case or for this particular challenge, so he is the ideal agent or he is the ideal engineer where I can develop the solutions, or where I can be, if I wanted to build some web pages, I can coordinate with the front end engineer. So that's where the team leader will know. So here also in terms of where we will have the state graph, or we will be having the master node where it will be decided that okay, we I need to be activated this particular node. So that's where the node in terms of node we are going to utilize. Along with that, so where we will be having a memory management system as well. So in terms of memory management system, consider you are interacting with the chatbot system. So in a chatbot system there will be the multiple the questions the user might be requesting. So where the bot is responding to the each and every questions. Now consider where the user is requested for 50 questions. So we have to remember all the context together in order to provide the response to the user for each and every individual questions. So how we are going to remember the context? Well, that's where we are coming of the memory management, where in a LangChain or like in terms of the other tools, where we will be having a short-term memory, but in the LangGraph, where we'll be having the short and long memory together. So that's where we can capture the entire the conversation together, and we can store the information for the long term as well. So that is one of the beauty of the LangGraph. So in terms of where we have developed the previous session as a LangChain, where we won't have a conversation memories or like in a memory buffer. So for the longer session, so where we can go with the only the short term memory, that is we can store into the only just like in a 4 to 5 the last questions which is user requested. So so the so these are the some of the core concepts which we are going to learn and we are going to implement into the today's session, like in how to define the graph and how to define as a state, how to connect, how to define the nodes, and how we connect it from one node to another node, and how do we create the memory management using the like in a conversation buffer memory or like in a short term memory or long term memory, and how do we create a checkpoints, and how do we create a tools like in a so the tools level we are going to learn in upcoming sessions as a name. We have a name MCP, the session separately, like in a where we are going to discuss all together. And so along with that, we are going to have a some traceability, like in how we are going to monitor and how we are going to defend this architecture and everything, which we are going to learn together today. And these are the some of about like in a the functionalities about the LangGraph which we are going to discuss today. Yeah, in terms of here, like in a why I'm saying the difference, why the LangGraph is the preferable compared to the other the frameworks which we have into the market. So other frameworks like in a LangChain, which we can see that like in a where we won't have any like in a like a stateless execution. So in terms of like there is no kind of like an saving into the context information. So there is no memory management into the other frameworks, like in coming to the LangGraph, where you can see the threads and everything, each and every the conversation, each and every checkpoint can be stored into the every thread is nothing but the where we'll be having a unique id. For example, as you can see, this is the unique thread id which we can say that. So that's where we are going to create the thread based approach and which we can store the information. And in terms of the traditional based approaches, where we won't have the tool integration level as well, like, and if I wanted to connect to the service node, or if I wanted to convert to the database, or if I wanted to convert to the Snowflake, or if I wanted to convert to the REST API, or if I wanted to convert to the web-based app, like an web scraping tools. So where I don't have any the custom integration tools, where I have to build like in each and every step together in the traditional based approaches, like in a LangChain implementation. So in terms of LangGraph, like you can directly just play with the 2 to 3 lines of code by calling the tool name and just to integrate by directly, like that's the beauty of this LangGraph. Like if you can see that why majority of the companies go with the LangGraph. So it is in a kind of completely customized approaches, where the users will have the where users will have a more benefits and to be integrating into this the solution. So even we can see here, like in terms of the business as well, like so when like while implementing this the like in agentic AI based solutions, where you can see the with the help of the memory context and everything, where it is increase the first call resolution up to 40% as well, and where we can see the reduce the time based approach, like an entire the execution process, like in terms of taking of one case to resolve for some 20 days or like in 5 days, where it is reducing the less number of days or less number of time which we can say that. And in terms of the accuracy part as well, where all the gates or all the nodes which are working as expectedly itself, each and every agent will work on the independent, and which is having a good accuracy, which I can say that that is we call as a the safer actions, like in terms of what action need to be decided to I need to be triggered for the front end, or I need to be triggered for the back end, or I need to be triggered for the full stack developer. So So based on the user query, which will the agent will be decided, the master agent will be decided, and this master agent will be invoke the right agent that we call as a right node, in terms of we can say that. So if the right node is not, if the right node is not invoked, then the, so entire the solution will falls under the fail. So that's where, like in a, when we are defining the agents or when we're defining the nodes and all, it should be like in a validated, and it should be whether the right node which is triggering, or we have to be verified, we have to be like in a thoroughly testing to be uh, to be uh, to be implemented. So those are the things which we are going to see any of, like in a, but just in terms of like in I wanted to explain like in a, so what is like an impact of the LangGraph and compared to the other agents as well. So as I mentioned, this is like in the beginning, like in a where we have the graph structured. So in terms of the traditional like in a LLM, where each and every LLM which can be implemented with the node level, and which will be have a, the node will be connected to the each tool, and where we can get the text summarization or text generation, or kind of identifying the entity extraction, along with the storing the long term and the complete knowledge base and persistent data in the LangGraph. So these are the things which we are going to see any of, like in a, so what is LangGraph and compared to the other agents.
సార్ డిస్కనెక్ట్ అయినట్టున్నారు ఒకసారి చూస్తాను. వెంకటేష్ సార్, ఆర్ యూ కనెక్టెడ్? maybe హలో వెంకటేష్ సార్, హలో. Give me 2 minutes, let me call him.
ఇట్లా ఉన్నట్టున్నారు సార్ మీరు.
Sir having some Wi-Fi issue. Give me 2 minutes, okay? He will be rejoining. Yeah.
Yeah, I'm so sorry for
Yeah, no problem. Proceed. Yeah.
yeah, I'm just sharing my screen. Okay, so these are the four the commands which we generally use while we implementing the LangGraph the solutions. So as I mentioned, which is the one is from the agent proposals. So where we define the what type of the tools which we have to be utilized. It's nothing but like in terms of where we are going to implement the LLM as a one agent, like in a where we are going to implement the LLM. Multiple LLMs, like in multiple large language models, which will be those the LLMs we call as an agents here. So I'm going to show you each and every agent as well in the detailed the project. So based on that, we can identify like in the tool, what is tool and what is node, how to implement the state graphs, how to implement the decision make nodes and everything. So these are the four steps which we generally utilize to implement any type of the agentic AI based solutions. Okay, yeah. So in terms of like in a while we implementing the any solutions into the agentic AI, so we have to always have to be remember that like in what would be the ideal security layers which are implementing like in a so if there is a information related to the personal information like in a so some of the files which we are there will be having the personal like in the names like in first names or last name if if those names are the identified in the user query, so how we are going to be encoded those particular the important informations like by using the pi or like an RBAC system. So these are the kind of some security layers which we want which we have to be implemented in terms of the various business use cases as well. So we always have to choose like what type of the governance layer or the security layer which we have to utilize, and along with the integration the points as well in terms of like if you're implementing this agentic AI solution for the ticket based system like you have this some incident, so where you have to raise a ticket. For example, we all working for an organization, so when we have an issue with the technical issues or when we have a facing of some network issues in our mission, what we do, we immediately raise a ticket in our organization portal. So this particular ticket will be routed to the right department where they can be helpful for to resolving the issues like in IT in terms of IT department. So like in a consider to raising the tickets and to implementing the solution step by step. If you wanted to do a automated system, this is where the agent AI will going to helpful. So it will identify the what type of the problem, so and in terms of the solution should be provided to the user, and along with that it will update the ticket status where it can be the step by step like in a the completely automated like in it is in a processing or it is in a resolved or it is a to resolved or like in a whether it is in a the ticket is in a status like in it is going to be assigned to the human agent. So all the in terms of everything which can be identified with the help of like an integration points like in a considering as in a ticketing system where you wanted to implement, so everything which can be implemented with the LangGraph based tool. So let's see the major the metrics in terms of like in how we are going to validate, how we are going to in terms of tell that like in our agentic solution is in a much accurate and much reliable. So like in a so where we are going to provide the checkpoints in terms of like in a what would be the processing time, and while calling the tools whether the input data which are encoded in a as for the regulatories like in healthcare regulatories or like in terms of the federal regulatories, which everything which we are going to consider in terms of the safety as well and the quality along with the efficiency as well. So what could be the ideal the cost of the calling the agent and how we could be save those so the in terms of the like in a by applying the cache technology or cache implementation and token usage implementation or kind of implementing the various solutions where we can where we can improvise our existing system as well. So those are the kind of some techniques which I'm going to show you as well in terms of efficiency. So model MVP is something which we are going to utilize for the upcoming session. So I'm stopping for here. let's jump into the code level. I'll just show you. Let me share my screen, other window. Okay, let's see. Yeah. So in terms of, before I'm going to explain, so this is how the real document. So consider you are working for in a healthcare department, or you are working for in a, for the healthcare industry. Consider like in some Merck, or like in a BMS, or like in a Optum, or if you consider for like in a J&J. So these are the Pfizer, or like in a, AstraZeneca. So these are the companies which are where they develop their own drugs. Okay, and once they develop the drug, they do the post marketing as well. So these are the post marketing, the reports which are going to collect it from the each and every the federation regular from the regulatory department, like which you can see that. So this particular report, which will be having the information of complete patient. So what could be the patient information, and the patient is located from the which geographical location, what were the date of birth, in terms of what is the age and sex and weight and height, and in terms of like if the patient is admitted to the hospital, like in what could be the ideal adverse event, or what was the patient is like suffering from the fever, or patient is suffering from the cancer, or patient is suffering from the asthma, or like in a, so these are the kind of information. So if the patient is admitted to the hospital, so where the management hospital healthcare professional will be going to collect all the information from the patients, from the considering his medical history, and from the in terms of previously the patient having any surgeries, or patient is having any health issues, or is their patient is consuming any drugs. So in terms of each and every details will be collected by the healthcare professional, where healthcare professionals, and those information will be feeded into the machine. So those the feeded information will be we are seeing in terms of this unstructured data. So where you will be having the document to document, all the information will be vary, but the ideal the fields will be the similar, but the defining of the form, or defining of the styles of this the particular fields will be the different level. Okay, so because the last week also, in terms of where we are discussing about, we want something, the real time data, where real time projects which we require, right? So this is the real time data which you are going to see on the majority of the healthcare industries. So ideally we will be focusing on the adverse event, like the patient is suffering the current condition. If the patient is unwell, so if the patient is unwell due to the fever, so those information will be presented, all the details will be presented into the describe reactions, which we call as a adverse event section. So where you can see the rash, patient is suffering from the rash, which you can say that. So in terms of the rash, what would be the ideal drug as suggested by the healthcare professional, and what was the daily dosage, and what was the units, and along with the, if you see here, the concomitant medicine, which is nothing but like in a patient is suffering from the diabetes, like in the diabetes case, like where the patient has to take the everyday drugs, right? Like in every day you have to utilize the medicine in order to control this diabetic issue, like in the sugar. So in order to what type of the medicine he was utilizing, so that is we call as a concomitant the medicine, which in terms of we call like if the patient is currently using any medicine, in terms of healthcare we call as a concomitant section. And if the patient is having the previous medical history, like in terms of last 5 years or last 2 years, where the patient is having admitted to the hospital due to the appendix, or if the patient is admitted due to some malaria, where his patient is infected with the malaria, or whether the other diseases, like in every the history will be captured into the other relevant history, or we called as a medical history. So here you see that if the information is not presented, where we can see the unknown, or it like an empty information. And even we can see like in a why this particular report, if you see the manufacturer in it, manufacturer information, where you can see the Pfizer as a company, which is providing the drug, this particular drug for the this particular issue, which you can see the patient is allergic due to the dialtin, so which is a drug hypersensitivity, where the patient is having the hypersensitivity issue. So for that, the healthcare professional is suggested the dialtin as a the drug. So this dialtin drug is generated by the Pfizer company, where we can see. So these are the kind of all the information which will be presented. But in terms of while seeing this document, where we can see that it is in a very easy, and where we can extract all this information in terms of by giving of this the simple returning the prompts. But if you see here, in terms of there are some field which will presented in the checkbox. So if you wanted to identify the report source, whether this particular report is prepared by the study, or the prepared report is prepared by the literature, or the report is prepared by the healthcare professional, we need to identify which is a box which is marked. So here, in terms of here, this particular the field, if you see, where we have the field which is marked as the tick marked as a healthcare profession, like in many fields which will be having the as in a checkbox, where we have to identify the what which checkbox which is marked actually for this particular field. So in terms of, if you have the particular field name and you will have the value, then easily we can extract. But when you have the check boxes, so you have to identify the right information, and you need to extract for the you need to extract the right value for the particular field. So today's example, today's the project, in terms of where we are going to develop the agentic AI based platform. So where it will identify the various sections, as I mentioned, suspect drug, and the reaction information, and the manufacturer information, and where we can see the additional information in along with the lab test also, where we will be having. So where the what could be the lab test which is performed for the particular patients, and all the details. So we are going to implement the solution in terms of to identify these particular sections and to extract the right values. Okay. So how we are going to automate this process, in terms of so we are going to implement the multiple agents for each and in every individual sections, and each and every agent will going to work on the specific the sections, and it will try to extract those values. Okay. So you can see another document as well here, in terms of the structuring of the information is completely different. So the system which you are going to design, it is like in a generic system, where it should be supported for the where the user provides any type of document. So because each and every vendor, each and every partner will have their own formatting style, right? They have their own form styles. So our solution should be supported for the multiple forms. So irrespective of the information which is presented in the first page, or if it is presented in the 10th page, it is like just have to go with the section level, and it has to identify what could be the ideal information we need to be pick up. So if you consider in the previous document, so this is the story. So from this story also, we have to identify the right fields. In if the information is not presented here, we have to tell the system to go with the additional information and try to focus on this particular field, and you have to extract. Okay. So this is something which we are going to work on. So it's all about unstructured, and it's in a context learning, which I wanted to say that. So in the context learning approach, where we are providing the each and every document, it is going to extract the various fields which is predefined. So let's go and see. Okay. So this is the streamlit. Okay, where I'm going to upload the document which I shown you now. So these are all the documents which is collected from the various partners. So you can see, so on the particular document, like in a Tejin, where we can see the Tejin. Okay. Yeah, you can see this is the one more vendor, where we'll be having the information in the different format. It's like similar like in a CMs, but some of the fields are like in a different. Okay, this is the document where we are trying to process to the system. Okay, so like these are the chunk total characters it is identified for the chunk one and chunk two. So I'm going to show you in terms of the code level step by step, but generally how it will run, and we are going to see where the user will come and upload the PDF files. The agents will be triggered, and each and every agent will work on the different sections, and it will extract the structured information. So this is the input text which you can see. So you might have the query that the Venkat, what if case if there it is in a scanned document. So in terms of the scanned document also, we have the solution like in a where the tool where the agent will identify the whether the document is a scan or it is a non-scanned document. Based on that, if it is a scanned document, where we will be the agent will trigger the AWS Tesseract service or Azure Doc Intelligence service in the backend. So the agent will be decide whether I wanted to trigger the Tesseract platform or not, or if it is in a general PDF reader where I can go with the customized Python functions. So then it will extract the particular text information and it will take up the decision. So if the PDF document is in a scanned document, then the agent will decide, okay, this I'm extracting the zero tokens in terms of this particular document. So I need to activate the Tesseract tool and I need to extract the text. So you can see that. So the entire text which is extracted the suspect drug list. So in terms of the suspect drug and the dosage unit and the frequency, the route of administration and the formula indications. So these are the various fields you can see that. So consider you have a one P of the patient document. So inside the patient document, there are multiple fields which will help majority of the healthcare industries about this information, like in how their drug is performing into the particular patient. Okay, and what was the dosage level after taking of the particular drug. So is there any side effects which is caused for the patient? So what could be the ideal the other drugs which has been provided by the healthcare profession. So in terms of they wanted to identify the drug behavior, okay, after the releasing into the market, we call as a post marketing analysis, we can tell that. So in terms of if you see there are multiple drugs, if it is there, so it will extract the nested as a JSON. In terms of just I'm showing you the raw list, but we will be having the structured output where it will be stores into the database like in the backend, where we will be having the RDBS systems and the MongoDB server, MongoDB's the databases along with the proper like in where the user can extract the in terms of the file format like in Excels and everything. Okay, so you can see the concomitant medicine as well. So where you can see the reported list where the first name, the who is the this report is prepared by that is from the which country, is mail ID, is postal code, and all the details which you can see that patient information as well. And you can see the medical history and the adverse event list, like what was the event means what is the behind of the patient to be admitted in the hospital, like the cramps in the claps. Okay, so this is a particular condition. You can see that even the information of whether the condition was a serious or non-serious as well. So where we can identify all this information as well, and who is the organization who is provided by this the drug, and the details of the organization of the drug and everything, lab details as well, you can see that. So there are more than 140 fields we are trying to extract here. Okay, let's go and see the one more file here. So before I'm jumping into that, I just wanted to show how the process will come. Okay, let's then after that we'll see in the step by step implementing the LangGraph solution. So the CMs one is the document we are processing now. You can see the CMs one. Okay, so where you can see that the particular event. So the patient is admitted the hospital due to where the patients have the like in a relieved in the moment, which is so where the patient is taken the drugs. After taking of the drug, like in a patient has suffered the pains in the leg. So due to that, where the patient is admitted to the hospital, this is the information which is presented. So for that, what would be the ideal drug as provided by the healthcare professional as a doctor, where you can see that, and how the dosage level, how daily, frequently the patient has to utilize, and you can see. And these are the medicine which is the currently the patient is utilizing, which you can say that. Okay, and where the patient have a historic is that, where patient is having the diabetic as well. Okay, so this is a kind of some information. So let's see in terms of how our extraction process is extracted. Yeah, where you can see clearly the frequency and the formulation, when the therapy started. So for a number of days, the doctor has the suggested for the patient to take this particular medicine. And where you can see the other information, other drugs as well, in terms of the suspect drug. So along with the current medicine also, where you can see that this is the current medicine tot lip, where we can see the medicine information as well, which you can see the concomitant medicine. So the report list and the patient information as well, which is taken from here, medical history. So here you can see the adverse, so the patient is having the pain legs, is having a pains in the legs. So that's where whether the patient is recovered or not recovered, also we can see that whether the condition is a serious or non-serious as well. Okay, so do you guys have any questions in terms of now for this particular project? So basically we are trying to do here we will be having a set of documents. So each and every document will be the unique, because as I clearly showing, this document will be which will be prepared for the particular patient. So if you consider each patient will have their own the medical issues. So these medical issues we are trying to extract in terms of the structured approach. Okay, so let's jump into the code level in terms of to see this project. So this was one of the project where we are, many of the healthcare industry have the challenging, because majority of the documents which are into the unstructured information itself, they wanted to be get into the structured information. This is where these are the tools like in the GenAI based solutions, where implementing to the majority of the organization, where they can upload the documents and they can get the structured information. Yeah. Yes, Sai Kishore. But in terms of here, where I've created the dummy reports here, it is not the original how these the documents which will look like, which I'm going to show you. So which is not to the related to the kind of patient. So where we have created the dummy information in terms of like how the document should be there in order to provide the solution. Yeah. So let's share the code. Let's just give me a moment. I'll sharing my notebook so that I'll walk you through the step-by-step approach. Okay, let me share my file. Let me share my screen. Just give me a moment. I hope everyone see my screen. Uh, in terms of tools, like here, I will be using the databases, but that is for to store in the extracted information after the process which we completed. Okay, let's jump into that. Okay, so first we'll have to import the packages like so the first the in order to implement the agentic AI solution, so we have to utilize the LangGraph. So we'll install the LangGraph package. So pip space install LangGraph. Okay, so I already have set up the LangGraph, but in terms of to show you in the thing, like I'm showing you. Okay, so this is how we are going to install the LangGraph. So if the package is already installed, that's well and good. Then let's import the packages. Okay, so these are the packages which we are going to utilize. So I'll walk you through the each and every project. So import OAS. OAS is nothing but like we wanted to define like the input files or the output files where we wanted to store. And in terms of the JSON, like we wanted to store the final output file into the JSON format. So that's where we are using the JSON package. And next, like where we are using the data type format, like in terms of the variables which we are going to define. So what type of the particular variable which stands for that, whether it is in a type dict or it is a list or it is an optional like so this will helpful for the classes where we are going to implement the pydantic based classes, because as I mentioned in the document where we'll be having the multiple sections, so each section will having the various fields like as in terms of the AE or AE start date or AE end date. Okay, so all those pydantic classes will be handled with the various data type format. So that's where we are using the typing from space typing, import optional and list. And the another one is the collection, which is we wanted to assign the default dict. And follow with that, a majority of our input documents are into the PDF format. So that's where we are calling the PyPDF, the tool, where we are installing the PyPDF as a package. Then from there, where we are calling the PDF reader. And the pydantic, as I mentioned, like in terms of the agent response, if we wanted to get the standard response, where we wanted to go with the pydantic based tool. Okay, pydantic based approach, where we will get the proper structured output from the LLM response. Otherwise, like where we'll get the string based informations, and it will be the completely the each and every field information which is a completely unstructured, the response of the LLM. So in order to overcome the unstructured response from the LLM. So we are going to define with the pydantic based classes, so that we can get the expected response should be in the structured appearance. And we are going to use the LangChain as a LLM models, which I told you in order to implement the LLM models, where we have to rely on the LangChain framework as well. So inside the LangChain framework, where we are going to use the Azure Chart OpenAI. So our implementation solution, we are consuming the Azure OpenAI models like in a GPT-4. So like in Azure Cloud Computing, which I can say that. So that's where we are using the Azure Chart OpenAI. And in terms of the response of the LLM model, as I mentioned, along with the pydantic classes, where we are going to define the JSON output parsers as well, and the prompt template, like in a how our agent to be taken the decision, so that the decision be steps which can be written in the prompt template, like in a, how it has to be considered, how it has to be find out the prompting, like in a where we have will be having the instruction and persona, step by step, few short example, business use case example, all the details will be presented in the prompt template. And then the LangGraph here is the main the component which I can say that. So as a LangGraph, so LangGraph is the tool which are going to convert the like in if you which are going to connect all the agents together. So in order to connect the multiple agents, where we are going to implement with the LangGraph, that is we call as a agentic AI platform. Agentic AI is nothing but where we are going to use the multiple agents. So when we are using the one agent, where we can do with the LangChain, But when we wanted to integrate with the multiple agents, that we can go with the agentic AI based framework like in a LangGraph, which I wanted to say that. So each agent will be integrated with the state graph. So each state graph will be having the state graph will be decided like in how many of the agents we need to configure, and what could be the sequence of the agent should be taken the decision. So all the information will be defined in the state graph itself. And the recursive character splitter, this is for the document chunking. As I shown you, these particular agents will have the limitation, so it can accept the certain token limit only. So what if case if there is an hundreds of pages of documents you have, so for that we are going to do the chunking. So this chunking will help us to identify the number of output tokens in the LLM response as well, because each and every LLM will have the token limit like an 8196. That is a maximum 8196 words it can be find out the final output in the LLM side. So if more than 8,000 word, then the LLM will break the particular the output response. It won't give the structured information. So that's why to overcome those issues, where we are doing the chunking technology, like in a there will be the recursive character splitter and the token splitter. There will the recursive word splitter. So multiple text splitter techniques which we have. So those techniques will be utilized here. Okay, so once you install all these packages, so majorly you have to focus on the LangGraph and Azure Chat OpenAI and Pydantic model. If your input files in the form of PDF, you can go with the PyPDF packages. Okay, so if the page is like in 1 or 2 pages, then you no need to do the chunking technology as well. Like in a no need to, it's not required if it is in a lesser pages. Okay, so let's define the schemas like in a the in terms of the sections. Okay, let's take the one section here, like in a the adverse event or section, or like in a medical history. Yeah, here you can see the one section which I've taken the suspected drug. Let me add another section as well. Like in, I'm going to show you all the sections together as well. In terms of showing you here one section. So here you can see the suspect drug, as we see that if the patient is admitted to the hospital, so for the particular problem where the healthcare profession will be suggested some kind of the drug, right? So those drugs we call as the current drug we call as a suspect drug here. So you can see the pydantic here. That's why where we have imported the pydantic base model. So in terms of to get the structured output from the LLM. So where and even where you can able to manage the individual prompt level as well. For the field level prompting, the base model will be the ideal approach for your solution to be implemented. Like I have taken for the suspect drug, where you can see the extracted brand and generic names for the suspected drug. Identify that section and extract the information. Okay, let's slightly change the prompt here. Let me check the original prompt how it looks actually. Yeah. Okay, let's show me. Yeah, here you can see the how the actual the prompt field will be there. So while defining the prompt as well, there are certain steps which you need to follow. That is we call as a prompt engineering technique or prompting technique. So you are going to tell about your particular field, like it is called as objective, or it is in a prompt role. What suppose this particular field has to be work. See, your task is to review the entire document and extract only the product names, or that's we call as a suspect product names, including the chemical salt from such as calcium, sodium hydrochloride, and if present to the product name, from enclose the line with the index tags. So these product names must match specific characterization. Like in a characterization is nothing but what could be the ideal the information for this the issue, like the drug. And along with that, you can see that what it's supposed to be included while it's reading the information, while it's considering this particular the value is the ideal choose for this suspect drug, or it is a product name. So this is where we have written as a do's or do nots, which I can say that's in order to simplify. So what qualifies as a product? Extract the core product name that falls into the following characterization, like in a suspect drug, where the product suspected to be related to the adverse event. So this is where, right, for the current adverse event, what was the drug as recommended by the healthcare professional. So the document to document, it might be vary, like it is a suspect drug or suspect product also we can call. So the heading sections, like this is where it can be appeared in the structured heading like suspect drugs or suspect product as well. And along with that, it should be look like the concomitant medications, like take the concurrently, and interacting the drugs, like where the drug known or suspected to the interacted with others. And following with that, the other information, and where you can see see you can see the how the prompting is bigger. But this is what you see in the real time in terms of when you're trying to make the the prompt to be more generic, and where it should be work for all the edge case scenarios, right? So this is where you are going to define each and every prompt, what could be the ideal critical instruction you need to consider. So you must thoroughly scan the entire document. This is we call as a chain of thought, which I can say that chain of thought, which you're telling that when you're looking into the in terms of the text, the input text, where you have to go through the step by step approach, and where you need to scan the entire document by step, and you need to consider the metadata information in terms of the headings, the narrative sections or case description and the follow-up information, and extract all the in terms of the related to the particular product, and you need to provide the information. So this is some kind of in a chain of thought techniques, which I can say that. So how the prompt should be considered. And along with that, you can see for the other information on what to be excluded in terms of in a product numbering as well. Sometimes we see that the prompt is hallucinating, right? Hallucinations is happening. How do we control the hallucination in terms of to improve the accuracy score? So this is where we will going to write in terms of we are going to see the real time the issues, while you're running in the documents, where you sometimes this the product names which will be tried to extract as a product numbers as well, or in terms of the numbers, or in terms of the medical histories, or in terms of the other sections. So how we are going to overcome as well, even the information will not be present into the input document or input provided text, but the LLM will might be hallucinate where it has learned, the way the LLM has learned from the data, where it could be provided from that solution as well. So that is we call as hallucinations. Even some of the scenarios where we observe that the few shot example, where you can see here what could be the input action, what could be the output action, what is the correct input and what was the incorrect output as well. Sometimes it will pick from this few shot example as well. So we should be clearly written in the prompt. It should not pick from the few shot example from the provided prompt template as well, where we have to written clearly as well. So sometimes there will be in the provided text there is no in terms of the dosage information, or the kind of indication information, in how much the dosage of the particular patient should be utilized. So if we have written into the dosage information in the product template, in the prompt template, so sometimes the hallucinations which will the prompt will pick up from this few shot example, but it's supposed to be written as unavailable, but it is picking from this few shot example. How will we control those information? So this is where in handling the rules, special handling the rules, where you have to go with the while considering how it has to be considered. And in terms of if you're working for the cross region documents, like in Japan Chinese, or in a French document, so in terms of their uh, local native language documents, so how you are going to identify, so all the information which have to be provided here. Even you can see the confidence score as well, in terms of the confidence score, when I'm saying that this particular field, the value is paracetamol, so what is the confidence interval which I'm saying that it is a 95 or it is a 90, or it's a 92, or it's in terms of 100. How confident the LLM is providing this extracted value as well. In terms of that is we call as a LLM as a judge, if we can remember all. So how will we evaluate the LLM performance as well? Even in terms of we wanted to identify, right, why these particular the LLM is given as a paracetamol. If I have the cisplatin as a drug, or if I have the other drug, so why only paracetamol it is provided? Because there is some there is some interlink which will be provided, like where this particular drug is connected to the particular event might be required, right? That relation it should be identified. So how it is happening, how contextual it is, the system is deciding, the agent is deciding. So that's where we are going to see that this all the informations which will be retained. So this is final check before submission also, like that's where the React agent which I told you. So the reacting agent prompting style, like where you have to go think step by step and analyze your extracted products which is generated, and the following execution exclusion rules provided above to that, where it have to exclude the adverse events and conditions, avoid the duplication of the same product, and it should be discrete. It should be what type of the other fields which has to be excluded. If the no valid products are presented, it should be written as unavailable, as we are telling that the prompt should be written as unavailable. So this is how the prompt will be written. So I just given as a standard prompt here, because but in terms of like in the real time when you're working with the industries, so how your prompt supposed to be look like, I'm just giving of that. This is the some of the prompt which we have utilized in the industry for the one of the field which I wanted to show you. So this is how we follow the prompting template as well, in terms of like extracting the fields and everything. Okay. So like you will be having a doses with unit, you will be having a the prompt, and you will be having for the frequency and all together as well. Like if I wanted to show you for the another prompt as well, let's I'll show you for the strength units, like in terms of the unit. See, see. Oh, my bad. Yeah, here you can see the in terms of for the doses and dosage units here actually. So the dosage units, how it's supposed to, your task is to review the entire document and extract the strength units or the units for the given product, which will be enclosed with the kind of index tags, and what should be written, and how the output of the format it's supposed to be there, and what could be the index rule, and the final the chain of thought, like how it's supposed to be considered, like in a step-by-step analyze and everything. So the field to field the prompt number of characters will be vary. So it's all about we have to see that like how complex of the particular field, and what could be the ideal the informations which are causing the issue. So we have to consider in terms of all the fields, and basis on that we have to design our prompt like so it's all about trial and error by running with the multiple documents with the different the the forming styles. So then only we can able to see, and accordingly we can enhance our the prompting as well. It is not like in a one day where we have designed this prompt. We have kept for many days, like we have run for the multiple documents, and then we have identified that this is the one standard format, the prompt where we can be utilized. Okay. So okay, let's run for this the section. So in terms of like in order to get the structured response from the prompt, this is how you are going to define the pydantic based classes. So where you are going to define what could be the ideal the the particular the output of the field in terms of the data type, whether it is a string or integer, or whether it is a dict or whether it is a list. So you are going to provide the clear the outcome of this variable. Along with this the field where you are going to write the description, in terms of the description is nothing but the prompt template actually. So where you're how this particular field has to be focused. Okay, so each and every information which has been designed here. Okay, so we are looking for the two sections. Okay, let's run for the two sections here. Now once you define the class where you have to wrap those the pydantic classes in terms of the base model as in the list format. Okay, because each class where we'll be having a multiple fields. So we are combining in the list wrapper, where you can see this is how we are going to wrap into the list when you are working on the multiple fields as well. So let me now to implement the LLM model. Second. Yeah. So here, this is how you are going to initialize your LLM. So once you initialize the LLM, so the Azure Chat OpenAI, where you are going to provide your OpenAPI keys, and even we have discussed in the last session as well, in terms of how to get those API keys and API versions and the model selections with the help of like an Amazon Bedrock services, where we have seen and we have called. So just I'm adding that particular cell in order to just to not to reveal. So now another function where we are going to define the prompting. Okay, this is where the create agent we are doing. Okay, so in terms of this particular agent, where we'll be having the pydantic classes which we defined in the above cells, along with the LLM as well, the large language models, where we are utilizing the Azure Chart OpenAI in terms of the GPT-4. Okay, and we are defining the two more the code lines in terms of to get the response output. As you can see, the schema class, right? The schema class which we are defining in the above cells. Okay, how it's supposed to in terms of those classes, it should be written in the JSON output parser. So that output parser we are making as a format instruction in terms of to passes to the LLM. So this is where you can see here the final prompt. Here in the prompt, final prompt template, which looks like something in terms of we see the prompt level. So this is how your persona will be there. This is your master prompt, which I can say that. You are a highly intelligent and accurate pharmacovigilance case processing system, which is designed to extract the relevant information from the provided input text. So this is a high level of the prompt, which you can see that the persona is the one of the technique which will tell that means persona is nothing but the person, which you can say that like in how the Venkatesh should be behaved, what is the Venkatesh roles and responsibilities. So Venkatesh is working for the which industry, like in a healthcare or like in a working for the banking industry or working for the semiconductor industry. So myself, I'm telling that like in a where I would be where is my expertise skills. So in terms of the expertise cells, where we are defining the roles and the roles of the particular agent. So your task is to carefully analyze the input text, where you have to identify and extract the information which is specified into the specific format section only. As I told you, the format section in terms of like in the classes where we have different each and every field, what should be included, what should be excluded in the prompt, right? For the multiple fields, those fields which we are trying to get from the final response, that is where we are given the task of the task defining the roles here in terms of the prompt as well. So this is how you're going to define your prompting as well. Okay, so let's run for this here. And in terms of once you create the agent, okay, so we are going to call the graph. Like this is where the graph nodes will come here. Like in terms of as we are discussing in the LangGraph will works based on the state graph level, right? Okay, so where I'm going to define the graphs. So this is the one of the class, like there are two sections which are focusing, right? Means two agents, so each section will have the one agent, like in a suspect drug is a one agent and adverse list is another agent. So these two agents we are going to call, if you have multiple sections where you can going to add the multiple graph states as a name agents, which you can say that. So each section, like in a 12 sections or 12 agents we can define. Okay, in terms of if there are more than, if you have 20 sections, then 20 nodes you are going to define the graph state as well. Okay, like how will we define the graph, how will we build this agent? Okay, how will once you define the class, how you are going to connect from the one section to the another section, that is we call as a one agent to the another agent, right? So this is your build graph. You can see that there are two agents, which is for the suspect drug and which another is for the adverse event here. So these two agents we are going to call with the node to node with a node. So the node is nothing but we call as an agent. Okay, so before we are going to call the agent, first we have to define the graph. So the graph state is nothing but you can consider as a flow chart, like in a way. So the flow chart where we know that the start button will follow with the decision node, like in a consider you have to see the decision, like in if it is an afternoon or if it is an evening, okay, where I have to go with this specific restaurant, or if it is an afternoon where I have to go for this specific hotel, or if it is in the morning where I have to have the breakfast in my home. Okay, how do you decide? So these all the steps, like and you know the step by step, like and for this your daily day-to-day routine, what is your the day-to-day planning, so that all the planning steps can be implemented with the graph state. Okay, so the graph state is nothing but the state graph is nothing but the ideal steps which you are going to perform the day to day. Okay, so once you define the state graph, this is the state graph, these are the only the two actions you are going to perform. So those two actions will be defined in the state graphs. Then after you are going to define, so first what could be the node you have to call, or what could be the action you need to perform. If first I have to start with my breakfast, so breakfast here is nothing but the suspect drug which I'm defining here. Okay, then follow with that I need to work on the adverse event section, that is with the lunch, you can say that. So first it will go for the suspect node or suspect drug section. Okay, then that particular agent we are defined with the node level, so each and every LLM agent will be called with the node only. So whenever you are saying to someone how did you define your agent, so that agents will be defined with the help of nodes, so each node will call as a one agent here. So you can see here in terms of the document as well, the function or runnable, this node will run, and if the string is provided, it will be used as a node name, and action will be used as a function or runnable. So function is nothing but the agent here, we can say that. Okay, and it is a set entry point also where you can see. Okay, set entry point is nothing but, so as I mentioned the graph, right, the flow chart, like in how it start and how the next item to be pick up, whether the once item is completed, what could be the other item need to be pick up. So all this can be followed with the entry point with the suspect node, then follow with the add edge where we are going to combine the step by step, like in a with the approach, like in the in terms of the edge flow. Suspect node follow with the AE node. Once AE node is completed, then the system will be end. Okay, if you have another node like in a medical history, what you are going to do, you are going to add one more edge, like in a in terms of like in a AE node you are going to define, and along with the medical history. Okay, so this is something is going to be the your end node. Okay, medical history will be the end node in terms of if you wanted to add more number of the agents or more number of nodes. So this is how you are going to define, even you are going to add your agent also here. Okay, okay, let's run this solution. Okay, now let's see other two utilities. Okay, this is in terms of the LangGraph, so there is nothing much you have. Just you have to first you have to create your agent, then those agent will be going to call with the node, that is the node can be implemented with the state graph. So you have to define your state graph in terms of number of nodes you are going to utilize for your execution process. Okay, so this is the state graph which you are going to call, and in terms of the nodes you are going to define, and the set entry point, like in way from which, like in step it has to be started, the date should be started with the breakfast, follow with the lunch, and follow with the dinner, like that. Okay, that is we call as a entry points. Okay, so now let's go with the utilities functions like in a. So now we need to know, we have to identify that how we what kind of the input information we are going to provide to our agent. So in terms of if it is in a PDF document here, where you are going to use the PDF reader, where this is the package, like in a the PDF reader, which will identify if it is a readable document, it will extract the information page by page, and it will store into that empty text variable. So in terms of we are working for the large number of document, this is where the recursive characters text splitter will be there. We call as a chunking technology as well. Okay. So once you've done with here, this is something post pre-processing utility, which I can say that like, and once you extracted the information, so where you wanted to combine all together, that's where the iteration based of the matched results where we have added here for the post pre-processing after the LLM response. Okay, so let's do by running the step by step here. Okay, this is my input documents where the path is located here. Okay. Okay, where I have read the document. Okay, so you can see the text information, which you can see clearly. All the text information is presented here. Let's see. Yeah, so you can see all the text information which is I received. So yeah, you can see it's a completely unstructured text information, which you can see. From here, you have to identify the specific field. Let me run the chunking. Okay, there are two chunks. It is taken based on the chunk size. We have given 3000, but you can increase for the up to 8000 or based on your the requirement. So now we are building the LangGraph like in a. This is where the build LLM, which will call the LangGraph here, as we have defined here build graph. You can see that where we have connected the nodes and where we have connected the agents and everything. Okay, let's call this one. Oh, graph state I have not called. Okay, let me call the graph state. Yeah. Okay, yeah, it is executed. Yeah, you can say that. Why I told you the flowchart or in terms of the graph. So we have the start node. The start as soon as the start node is implemented, it will trigger the suspect node and it will trigger the AI node. The agent will decide automatically. Okay. Even in terms of you can define your customized approaches as well, how it's supposed to be taken. After the suspect node, if there is a drug which is identified, it is identified related to the cancer drug. So what are the other steps which you wanted to run? What are the other agents should be triggered, where you can define that information as well. So that every information which you can see in the graph level. Okay, let's run. Yeah, where we are running all the chunks together, where we are invoke, where you can see that. Okay, invoke is nothing but where we are invoking the agent, so which is running. Okay, which is run, where we are combining the final results with the merge results, that is we call it, as I told you, the post pre-processing, right? So even you can see the result states as well. If you can print, you can see the output in terms of that. Like, and you can see the output structure, which is we got the proper standard structure. Okay, so so now you might be have an understanding about why we use the pydantic classes in terms of the field level, and then the JSON part output parsers and the format instructions. So it will helpful for you to identify to get the final response in the structured way. So where you can directly store into the particular databases, or where you can perform like in the analytics, like in detailed analytics about the how the drugs from the patient to patient behavioral analysis and everything which you can perform. Yeah, this is for the one project. Okay, the another project which I'm going to discuss you about the claim insurance approval agent. which is also from the LangGraph. Okay, so do you guys have any questions? I'm pausing for 2 minutes. Yes, Srikanth, it is in a kind of linear graph where you're going to follow the step by step. Yeah, go ahead, Vamshi.
Hi, so I have a question. So, LangGraph will help you to do recursive agentic flow, right? But you showed
Yes,
the sequential flow. In order
yes.
to do the recursive, like I mean,
Mm.
how do you implement the architecture? So,
Yeah, I'm going to show you the next project that is also like an where it is going to the recursive based approach. What
mm-hmm.
node to be triggered, the React agent based tool, everything which I'm going to show you. The next project which I'm going to show you.
Okay. And then like to create an agent, like basically use the LangChain, right? So in order to, otherwise we can also use the OpenAI stick, right? Which is better in this creating agent?
No, see, for creating the agent, I used for Azure platform. Okay, but the LangChain is the ideal framework. Even within
Mm-hmm.
the LangGraph also, we can implement the LLM models. It's just about the LLM, which LLM models you wanted to utilize for you to take the decision. That's all.
No, no, I know the LLM model is the one who give us the result. But on top
Mm,
of it, we have a wrapper called agent creation, right? Agent use the LLM to make a call. The agent creation, you are using a LangChain here, right?
yes,
LangChain framework.
yes.
Okay. So in like instead of LangChain framework, shall we go for OpenAI SDK or anything, which is
OpenAI, yeah, we can go. We can go. OpenAI also we can go.
okay. So which is better, like in terms of performance
LangChain
wise?
is better. LangChain is much better because if like in terms of if you're working for Azure also or if you're working for Amazon, so where you
Mhm.
can implement like in the both platforms with the LangChain. But for OpenAI, it is specific for that particular platform only. If you want to look for the multi platforms, LangChain will be the ideal approach.
Got you. And then like you say the token limit, right? Token limit is 8,000 tokens for each
819.
of the LLM.
Yes, yes,
So to avoid the problem, we have to go with the chunking, right? Basically,
yes,
let's
exactly.
say like you have a document with 10 pages of PDF.
Mm,
Like, do you save like how many chunkings will do and how you get the result back? Like for each chunking result, how do you
okay.
combine it back?
Yeah. So what we do for like and as you see in my screen as well, like in
Mm-hmm.
terms of once you process like and there's a parallel process which a distribution system we are going to apply here. So
Mm-hmm.
each and every section what you do, it will extract all the information in terms of the nested dictionary, which I can say that it can be appended all into the empty list, and then we'll
Mm-hmm.
get the final response as in terms of like these are the all the information which we have extracted. Even we have observed which we call as a large output parser, the technique where
Mm-hmm.
even see this issue will not for all the chunks will happen. Now consider this particular chunk where I have more number of outputs. Okay, but when coming to
Mm-hmm.
the second output, I have a less number. So then what I do for this particular chunk only, I'm going to do the rechunking as well. Even I'm going to break into the smaller chunk instead of 3,000 or instead of 3,000, I'm going to make the 1,500 in tokens only. So from there, I'm going to run for the LLMs again. I'm going to run for the agent. I'm going to get the extract. I'm going to get the response. Then I'm going to combine all the response together in terms of the post pre-processing, and I'll make a single output.
Mm-hmm.
So we can handle with the post processing only, where we store all together in a one place and we'll combine all together, and we'll make the final response.
Okay. So one last question. So basically LangGraph, right? It maintains a state between the nodes. Okay.
Yes.
And each node will have a agent. And let's say your
Yes.
agent is making LLM call and due to network failure and agent is failed. So I think agent has a retry mechanism. But does
Yes.
a
Yes.
graph a node will wait till that agent to return back? And how do you control that behavior if such a scenario happen?
So what we do, we will have the like in a status agent where it will verify that whether the agent have successfully the completed the process or not, the completed the job or not, as we can say that the
Mm-hmm.
job state agent. So
Mm-hmm.
it will decide that. So based on that, it will decide like whether I need to reactivate or I need to rerun the particular agent job, or either I need to continue with the other agent job. So how crucial it is that. So we can control with the the job status agent.
Mm-hmm. Okay,
The
so there is
status,
separate agent. So there is
yeah,
separate agent who will maintain job status, and that keep checking the final output whether we got it in each agent or not. You mean that?
exactly. So I will show you in terms of one approach. One second.
Mm-hmm.
So all the agent status will be captured in the traces here, like in terms of like in a. So we can see here. One second. Okay, let me share my screen so that I can able to. Okay, so you can see that. So whenever the agent is triggered, for example, so where we are going to see that like whether the agent is successful, the status is successed or not. So these are the
Mm-hmm.
kind of the platforms where we can the monitor, and this particular the trace success or failure information will be captured, and based on that we'll decide whether the particular agent should be rerun or whether we can continue with the another agent. So we have the langfuse the technology as well, in terms of to
Mm-hmm.
trace the in terms of to see the success of the promptings, the success of the agents of the completed response.
Got you, Venkatesh. Yeah. Thank you. Thanks for your time.
Yeah.
Yeah.
Yeah, Nitin, you can proceed. Nitin.
Hello, Venkat.
Yeah.
So
Hi,
my
Nitin.
question, yeah, hello.
Yes.
My question is related with the another like from the non-coding perspective. There are the tools available like the NA10 and all the things.
Yes.
So is that also helpful to learn? And how will be the job opportunities for those tools? Like, is it mandatory to go with this LangGraph, LangChain only if we
No, no,
want
no.
to go?
See, I'll tell you, Nitin. See, it is all
Okay.
about the organization to organization. Now, as I see, the many of the organization they don't want to, spend much time in order to write from the beginning, from the scratch level. So where they wanted to go with the, the just like in a plug and play, as you mentioned, N8 or Google Vertex or like in a the various the playground tools which are available, where you can directly just you can drag and drop, and where you can control where you can connect all the tools like in a service now or snowflake or all the
Mhm.
mcp protocols and everything. You can do
Gotcha.
that, where you can directly define the llms also by connecting to the cross region interfaces as well. So as I mentioned, it's like it's all about depends on the organization, but it learning from the both level, it will be value for your career.
Okay.
Yeah. And
Learning
every other
both of
tool,
them.
Nitin,
Oh,
Microsoft Copilot Studio is another one that also help you
okay.
like a plan coder perspective. You can do
Yeah.
drag and drop. Yeah.
So
Okay, okay.
having the
So,
both will be added to you.
okay, learning those tools also will be helpful
Yes.
in terms of getting a job and all the
Yes.
things. So,
Right.
can I get the detail
Yeah, Nitin, we
like
have
you are
separate.
providing? Hmm?
Yeah.
Nitin, we
Sure.
have separate plan for non-coders as well.
Okay,
Yeah, ping me offline. I can help you about that
yeah,
course.
okay. Actually, I gone through that details which are provided into that PDF.
Yeah,
But
yeah.
yeah, but that doesn't making much sense to me. So that's why okay.
You
I
can
will ping
call
you
me
separately.
because I can give you a clear explanation. Okay.
Okay.
Okay,
Let's.
okay, sure.
Yeah, I'm just passing for the questions for now. Let's because we are running out of the time as well. Like I'll spend another 10 minutes in the last after
Yeah,
the project.
Chandra and Tash will give you opportunity once the second project over. Okay, thank you.
Okay. So this particular project, it's for the claim approval agent. Okay, it's for the claim approval. So consider you're working for the insurance companies like there are multiple insurance companies across the global, right? Each and every the geographical location they have their own company. So for every organization there is a some certain process, right? When the user or when the customer submitted like applied for the approval for the insurance, like there are some certain steps which will be followed by the insurance companies like so these the particular the claim will be eligible for the particular disease or not, right? So where they will going to verify each and every in terms of their the insurance the benefits, and whether the benefits will be suitable for the particular disease, or like in how much like in what kind of the the uh, the refund which can be provided to the particular the users. Okay, so it's all about the step by step process where we'll be having some certain steps which they will go with that, right? So in terms of you consider, so where they will be having each and every reference code for each and every health disease. All right, if you consider there is a electrocardiogram where routine for the ECG with at least 12 leads with the interpretation and report. Okay, so if the user is submitted for in terms of the claim approval for the electrocardiogram, okay, so whether this information will be suitable for this CPT code or not, even this the CPT code will be applicable for the particular the healthcare benefits or for the policy or not, like in a policy in the sense like in where you can see the essential care as a one policy, and the Metro Prime is a one policy, and Family Plus is a one policy, right? So where you will be having the multiple policies like in a senior secure policy. So whenever you apply for the claims, like we see that many of the claims were rejected because that particular the disease or the particular the issue will not come under into this particular the policy plan which is taken by the user. So how they are justifying and how they are the the denying the particular the application. So it's like there are the plenty of the customer, the plenty of the back end people or the like the associates where they are going to work day and night in order to give the final decision, like whether the how much of the amount will be eligible for the particular the customer as for their policy plan, as for their policy benefit, as for their policy range, and as for their policy the sum insured, like in how much they have utilized and what was the amount over lefted. So within that, like in how much we can be provided to the particular the customer. So this is where something which we are going to work on. So where we wanted to make the completely automated, so for the claim approval. Okay, so like in how we are going to implement the insurance claim approval. So in terms of like if all the policies or all the some the steps, like which is we have the some predefined steps which are matching as per our expectation, then we are going to approve the claim where the user can approve for the particular amount. If not, if there is any queries or if there's something some more information which is required from in terms of the customer level, so where it can be routed for the reviewer as for the human. So these are the two we are going to identify. So as soon as we receive the claim, okay, so the claim is going to be approved or route for review. So in order to provide these two solutions as a final judgment, where the agent is going to perform the various steps. Okay, our main goal is to we are trying to create the advanced agentic AI claim coverage validation system. Okay, so what could be the claims and everything, as I mentioned, with the various policy names, various the healthcare codes based on the disease to disease, and along with that, these are all the steps which we are going to taken with the agentic AI the validation system only. Okay, and it is go with the various future level. Each future will have we have given the different threshold benefits, like in threshold rates. So considering in terms of the whether we have to approve for the claim or whether we have to send for the reviewer. Okay, so each and every future will be going to analyzed by the agents, individual agents, and then it will be the final the steps which are going to take. Okay, let's in terms of like I'll show you the architecture level as well. Okay. Okay, so if you see about the architecture level, okay, so where the patient will be going to have a patient validation records and the text record in terms of this project. Okay, so what did we do? First, we once we receive the patient claims, okay, where our system instruction will process the like where we will be having the system instruction prompts, and we will be having the supporting documents for the reference codes and the insurance policies as well. Now, as soon as we receive the insurance, like as soon as we receive the claims from the customer, first what we do, the summarize patient record, where it will activate the system instruction prompt, and it will act the React agent. So where it will try to look for the React agent, which will try to see for the this particular the claim will be eligible for the claim, the amount or not, whether you will be benefited or not, like whether the claim which is submitted by the user, whether it is whether it can be proceed or which can be denied. Okay, so for that, what it do, it is going to read the patient summary as a supporting document where the patient is going to submit all the necessary medical documents, right? What could be the ideal treatment has been provided to the particular the customer, and in terms of the all the patient summary informations which is going to be read by the agent, as it is going to verify the what could be the ideal record summary, what could be the ideal policy summary with the summary policy guidelines which is connected to the reference codes and insurance policies. And then based on the existing the policy informations and existing the policy benefit, where the we are going to take the decision by the agent whether taking the response should be the approve or route for review. Okay, along with that, we are going to take the justification as well, why this particular claim is going to be approved or why it is sending to the route for review. Because we need to see, right, whether if the as for the patient, like in the patient summary, the patient summary, like in a patient is suffering from the some diabetic issue, so where the diabetic for the diabetic treatment, where the policy will not suitable, like in a policy is not applicable, like and if the user is submitted, where we have to tell that, right, like in the as I see the patient summary where you have been infected by the diabetic issue, so for this particular treatment where this policy is not eligible. Okay, that's why we are rejecting or we are sending to the route for review. So those are the kind of the reasoning information which we are going to find out here. Okay, so let's go in terms of the code level as well, like in a just where we are going to see. Okay, so here in terms of all this, the packages will be the same here. So here in order to take the like in an earlier project where we have run with the sequential based flow graph and everything, right? But now it will we are going to run with the React agentic based style, where the agent will decide like what could be the ideal the next steps which need to be performed and which node it should be activated, everything which will be automated, like in every the steps will be completely in the parallel based approach. Okay, so I just imported packages and the LLMs. Okay, so this is where like in the input the supporting documents, like in which we are providing to the LLMs, like in as a part of the tools, I can say that. So reference code is a one type of the tool where it will find out the various references, and another one is the insurance policies, where we'll be having the what type of the insurance policies we have and what are the terms and conditions and what are the basic informations we are going to provide. And the test and validation records are the in terms of the to be in order to validate how our agent is working. Okay, so next, if in terms of if you are looking at the test records and everything, where you can see the patient date of birth, okay, or date of service. So some of the records, most of the records will be start with the year and month and date, or like in sometimes year, date and month as well. So we wanted to make the standard format. Okay, we wanted to make the standard format, that is we follow with the year and month date format only. So whenever we received in the date of birth, like in terms of the incorrect format, like in first we are going to validate and we are going to change accordingly, like in what could be the ideal date and month and year. These are the pre-processing steps which is going to be performed by the agent. Okay, then follow with the age as well, like in a where based on the date of birth, where we are going to extract the age as well, so number of years. And along with the code description, as I told you, like in a code description in some of CPT and ICD-10, these are the the healthcare terms which we have taken, but there will be the multiple healthcare terms will be there, so each term will be comes into the specific disease. Okay, if you see in terms of the CPT, there will be the certain disease which is comes, and in some of ICD you can see the diabetic related issues where you can see most of the policy benefits. Okay, so that's where it will try to figure it out, okay, what type of the healthcare the description terms we have. Okay, so now like and this is of one of the summary patient record. So where like in terms of to taking the one decision, like in about the patient details and patient summary and all together. So where we are trying to do first pre-processing steps of the particular, as soon as we receive the document, so we are trying to validate all the informations from the database, the connecting to the specific fields, like in order to extract the information. Okay. So based on the patient ID, like the insurance ID or the policy ID, where we are going to retrieve all the specific details related to the patient. Okay, with the policy ID information, the billing amount, date of services, and all together, and the summary policy guidelines as well, where you can see what could be the these particular the user, what is the policy details and what was the policy name, so what are the diseases it will be covered, and what was the sum insured amount which will be covered. So all the informations will be uh, collected from the summary policy guidelines. Okay, this is the one information which I wanted to say before the starting. Okay, so this is where we start with the agents. So the check claim coverage, right? This is the first agent, as we see in the graph, like in as we see in the architecture, where we'll be having the patient summary and the policy summary. Patient summary is nothing but the where the healthcare professional is provided related to the patient a disease, and the policy summary where we are going to, it is in a context information which I wanted to say that in terms of that, like in the policy summary which will be fetched from the database as a part of the tool. So where we'll be having all the policy details and the benefits and the terms and conditions all together. And you can see that how it's supposed to be evaluate the insurance claim coverage, like can I follow with the diagnosis codes and the procedure codes and patient agents and patient genders, and follow with the step-by-step analysis and final decision how it's supposed to be taken, and the reason to take up this decision as well. Write a single and clear human readable explanation for the claim processor as well, and the invoke of the LLM, as show you the agent. This is the one of the agent, I can say that the claim coverage agent. And the final reason is also where we are doing the post pre-processing in order to get that, because here we are not doing the pydantic based approach, we're completely doing with the pre-processing techniques and everything. Now here you can see the tools, where in terms of the tools how where we have defined, like in a these tools, like in a connected to the particular above agents, like in a summarize patient tool and summarize patient policy and all together. Okay, so now you can see that the tool check coverage, even you can verify that, like in terms of this particular application, each tool how many times it is calling, and how what was the ideal weightage it is providing while taking of the decision as well. That is we call as a check claim coverage as well, like in terms of like in tool summarization patient and tool summarize policy, tool check coverage policy and everything. So you can see that there is no the graph level here we are doing. It is completely in terms of tool level, where it is the system, like the agent will be going to decide, okay, what kind of the tool we need to be activated here. So here the tool in terms of the database, or in terms of the collecting the data from the patient's database, or in terms of collecting the policy database, or in terms of collecting the coverage information. So all the information can be decided by the react agent style approach. Okay, so where we don't have any structured information, so that's why where we are going with the react agent based style, where it will go with the decided by the agent, like what type of the tool we need to be trigger in terms of taking of the decision, like the position code and the diagnosis code and all information which is provided by here. And this is like as I mentioned, if the agent fails, or the while looking at the agent with the various feature, if few of the features if it is failing, then what could be the ideal approaches which has to be taken. So all the in terms of like templates also which we have given up as a fallback agents. So in terms of like whether the agent is getting a fail, or it is agent is getting of the success, so uh, deciding of those informations and all together. And where you can see the summary policy guidelines and all information. So these are all the kind of decision, the decision how it has to be taken, the reason, in terms of all the informations which you can see. This is the kind of the core level. If in terms of the one agent fails, what could be the ideal fall agent, and the one future if the information is not presented. So what could be the ideal next features which need to be considered, and what could be the ideal weightage it is providing. Everything which can be verified. Even you can see the validate the agent as well, the logic of the agent and everything. Okay, so let's run for this one. Okay, so you can see here it started the process. So it's running for the individual agent. So this is completely synthetic data which have triggered, where you will be having the when the policy is submitted by the user. So what could be the ideal details we will be collected from the backend level, like in a patient ID, name, date of birth, gender, insurance policy ID, diagnosis codes, and procedure codes. You can see that. So these particular diseases which will come into the which thing, and the specialty of the disease, like in a cardiology or the kind of orthopedic, everything which can be decided. So the billed amount also you can see that what was the, the amount which is paid by the customer. So that billed amount also we can see that, and the age in terms of and everything. Okay, so let's see the output in terms of submission.csv. Yeah, so here you can see the route for review and everything which is came here. Sometimes it will comes for the approve as well, like in a, so why this it's went for the route for review. So you can see the one reason. So where the patient's age is 43 does not meet the policy allowed range, that is for the 60 to 90. Okay, so where the senior policy, like in which is taken by the customer, but his age is 43. So that particular issue will won't be provided the insurance amount, or which can be the claim could be approved here. So this is something which we can tell them, like in a, so because of based on this issue, and this is the reason where we are denying your policy. That's where this is the complete the automated process which I can say that. Okay, so now do you guys have any questions, like in terms of the agentic approach and agentic style? So where you can see clearly there is, we are not setting up any graphs or state graph level, because everything should be taken by the system, what type of node it should be triggered, and what could be the decision can be made, and what could be the reason it should be provided as a justification to attaching that, whether I'm approving or I'm sending to the reason for review, or I'm denying this the claim, saying that this age is not suitable, or this particular disease which not comes under into the policy which is consider which is taken by the customer. So kind of the reasons which has to be provided for this one. This is the something which you can develop for in terms of like in a the ticket based system, or like in a claim approval agents, like in a completely different various tools and everything as well. Okay, yeah, this is for today's like in a the project for agentic style, like with the graph level, and with the completely the decision can be taken by the complete agents, like what to be taken of the necessary steps. Any questions now?
Yeah, please raise your hand so that we will prioritize your questions one by one. Yeah, so we will come up with one more project with theoretical tomorrow as well on the LangGraph. So that will clarify many of your questions as well. We spend 2 more hours tomorrow as well. Please try to join on the same time. Chandra, please proceed.
Yeah, thank you, Venkatesh. So I was listening to the project one and project two, right? In the project one, you basically created two agents and you actually chained them together. Here, you go first and then you go second, right?
Sure. Yes.
The starting point, and you created the edge, and then you did the third, right? But in the
Yes.
second, that is not the case. So, right? So, are there different types of agents? That's why we have to do this way. We're trying to understand.
Yes, Indra. So here in terms of like, and I'm not telling that like in a step by step you need to be followed, because if I tell if I'm developing that particular system, so it is where it should be processed. It is like in a time taken. If I have a 50 steps, okay, where the user won't wait for the 50 steps to be completed, right? So it should be decided by the system. Okay, if this particular the particular step which is successfully completed, so what could be the ideal other steps which can be going to be passed as well, or which can be successfully it will be completed. So based on that, the system should be taken up the decision, and it should avoid those steps by running unnecessarily, and it could be run the others agent. So that's where the agents will take up the decisions by themselves. That's what we call as a react agent approach. So react agent style, where the agents will go with the step by step by taking off if these steps are completed, so I can skip or I can run the other additional steps so that I can take up the decision without running the other agents as well.
Okay. So, and this React agent would depend on, I guess, what it will use as a brain to make the call. So the React agent itself has its own, let's say, LLM to decide on, uh, because at the end of the day, it has to know, correct?
Yes, it has one LLM where it will be decided. Okay, so this particular the agent I have sent this output. Okay, so this is my the output I expected. Okay, I got the expected output. Okay, then what could be the ideal next steps which I need to be decided? Okay, so with these basic confirmations which I can proceed for the claim, or like which I can be waited for some other additional, the
Mm.
decision which I need to be considered. So it will be decided based on the in terms of basic like an it will have some kind of context, right? Where if the context is matching like an 80% or the 90% of the confidence score, where it will eliminate. So that kind of the mechanism which we are going to write in the prompt.
Okay. Okay. And then in the same project, you talked about synthetic data, right?
Yes.
So I know because usually, especially for the medical insurance, right? These in the health care industry, the PI
Mhm.
is very, very important. So
Yes.
just
Yes.
wondering, how did you come up with this synthetic data? Do you have any used any tools or techniques to come up with the synthetic data?
Uh, exactly. So I will be using this neural network with the have some sample set of the data where I've created like in taking of the domain information. So there like in some 10 samples we have taken. So through the 10 samples with the help of variational autoencoders, I've generated the synthetic data.
Oh, okay. Hmm. Okay.
Because it's
And
a
then,
it's a very very important, as you mentioned, like without the PA we cannot we cannot proceed as well, even in terms of the demo also we cannot show. That's why before I started the demo, it's in a completely synthetic data, it's not the original data which I'm saying, but
yeah,
it's like similar to the original data which I wanted to say, the names and everything. it's
correct.
it's
Understood. So, yeah, just wondering, how did you come up with data? Because it seems to be a common problem across, all these sensitive industries, right? So that's why
yeah,
experience.
exactly. Yeah.
So there is separate.
Because I will be part of
Usually,
the organization, so where I'll be where I work for those projects. So I know, like we know, right? When we are working for those projects, like ideally, the
yeah,
what could be the style of the data which will comes up in the real time approach. It's not like a straightforward data which we see in the training sessions.
right. So your domain knowledge will help us figure out what kind of document you need to create, or what kind of test data you need to create. But then
Mhm.
the actual process of creating the synthetic data itself, you were saying use another tool. Is that how you understood?
No, exactly. See, this is about something which will boost your knowledge in terms like an okay, if we are going to work on these are the kind of issues like in how we have to build the solutions, what are the tools we have, like in how we have to drive the entire the project. Okay, slightly the original document might be varies, but 80 to 90% of the documents which I shown you, it's completely the match. It's a kind of it's a completely 80% of the matched documents only. 80% of the information will be matched. Slightly the layouts will be different, but everything will be the same most of the time.
And last question, and a lot of people may be waiting. Going back to the first project, right? So the way I understood is that uh, you took the initial input PDF file, you created a text out of it using some kind of a tool, like you said, something like some lit or something, right? Streamlit or whatever, right? Then
Yeah.
then you broke that into processable chunks, right?
True.
Uh,
Yeah.
then you ran the two dictionaries,
Mm-hmm.
right? Suspect and adverse. So I think that, each agent will go through all these strings and fill its respective goal, which is, hey, I need to, look for these specific, 15 fields. That's what the suspect will do, and then these are the remaining. These are the 20 fields I'm supposed to do adverse side. So that's how but they go through. Each will go through the entire chunks, and then basically pull the information that they need to look after.
Exactly, Chandra. It's all about the domain knowledge only, which I can say that because
Mm-hmm.
as for my experience with in terms of that, where I have been chosen, even if you talk about the generic terms, like if you are working for the job processing industry, like in a Naukri or like in terms of LinkedIn job profiles, if we talk about, so majority of these like the industries also where they wanted to extract the values for the specific field, like in an employer name or like in the employee name or
Correct.
what type of the industries he's worked, organization names. So it's all
Correct.
about they have their own set of fields in order
Correct.
for
Right.
their business use case. Similarly, these are the fields, common fields, which we see across in the healthcare industry side.
Gotcha, gotcha. Okay, yeah, so the input could come in different shapes, sizes, and formats, but we know
Mhm.
what is our target fields are, and that's why
Yes,
we created these.
exactly,
Okay,
exactly, Chandra. Yeah,
okay. Thank you so much.
yeah, thanks, Chandra.
Yeah, can I
Yeah,
go? Tash, can I go?
Yeah, hey, thank you for taking my question. So I have question, maybe it's more generic. So you were using the Jupyter notebook. How do we enable, is it something that we have to use in order to use that type of agents, multi-agents? Um, and the other question,
exactly, Tashi. In terms of like this is where the LangFuse platforms we Langsmith where we utilize like uh, so how the particular agent is helping us to take up the decision. So if the agent itself it is not providing any solution while processing the system, then there is some suspected issue might be there, right? Like why this agent is behaving like this. So where we collect the each and every agent metric as well in terms of the response. So whether the response like the score which is as we are getting, or like where we wanted to go with a different mechanism, or we wanted to be fine tune that agent by making of writing the different approach prompting, or what kind of the other steps which can be followed. So exactly, it is a call of LLM ops where we are going to evaluate each and every agent and how their performance and everything, the fine coming to the final approvals and everything.
I see. And so I think in your example, you put the medical PDF documents.
Yes,
If I want to pass the Figma documents or Figma specifications, is there a
we
way
can
we can pass
we can.
those?
So what we do in Figma, it might be not the readable text, right? As straightforward, it is an image based, you consider
Image
Figma.
and text, correct? Yeah,
Yeah,
yeah.
so what we do, uh, our tool will be agent will be decide on this given input document whether it is a scanned document or it is a digital document, is a non-digital document. Okay, consider if it is a non-digital document, if it is identified, where we will be having the other tool, AWS Tesseract services or Azure Doc Intelligence service. It will convert the Figma document to the readable document or readable information. Okay, those text information will be sent it to the agent as a part of that. Yes, we do have the solution by integrating this Tesseract solutions. We can do that.
So basically, we are converting the Figma into some kind of documents first
Yes, yes, exactly, exactly. There
and
are
pass.
solutions there. Yeah,
Okay, and okay, then yeah. Okay,
thanks.
thank you.
Yeah, Madan, you can proceed.
Yeah,
Yeah,
before
can you
Madan,
hear me?
Ash, if you attended the last session where I have shown the check case processing system, the checker, the banking check processing system, where majority of the all the checks are into the scanned document only. So where I've shown the how to extract the text, like with the Amazon Tesseract services, which I've shown them. So please you watch the last week session, so it might be helpful for you to getting
Yeah,
the photos, editing.
that would be great to watch. Actually,
Yeah.
unfortunately, I missed that one. Is that video will
Yeah,
be
it is there. In
available?
the last week, the last Sunday, we have given the bootcamp session day 2. So you can watch the day 2 session. So it will helpful for you.
From YouTube, or is there any
No,
other?
no, no. We have our custom the YouTube channel. Maybe you can reach out to the our mentors like in Kodandra or with Surya. So our mentors will help you on to getting the
Okay,
recordings
thank you
and
very
everything.
much. Thank
Yeah.
you.
Thanks, Madan. Yeah, thanks, Asha. Madan, go ahead, Madan.
Yeah, can you hear me?
Yes, yes,
Yeah.
Madan.
Yeah. So couple of questions. The project two that you have shown. Uh, so basically, you have created agent, and then you have provided couple of tools. So the
Mm-hmm.
LLM makes the decision which tool to be invoked when after analyzing the data, right?
True.
So
Exactly, Madan.
yeah. So is it the agent's responsibility to invoke those tools, or like LLM directly can invoke?
Agent is responsible. This agent is also configured on the LLM only. So, so the prompt, like the agent itself, it is decide. Okay. So what type of the tool it should be activated. So agent will
Okay.
decide completely.
Okay. And in the first project, so we have multiple agents. So between the agents, the context is passed through, like you said, it's going to save in memory, and it's
Yes.
going to pass the context, right? Like even the
Yes.
output also, like say I have like some output from agent one to be passed to output to agent two.
Agent.
Okay, so that also gets saved in the memory.
Exactly. There we are going to use a conversational buffer memory. So this will capture the entire information. Along with that, we are for longer term purpose where we are going to store the session ID. So for each and every query, there will be the thread ID or session ID will be created. So for that particular thread ID, it will be stored into the MongoDB, and part of that entire the next user query. If the user is going to try the next question, so it will going to fetch the entire the previous conversation as well, as we keep the n number of conversation like 10 or 15. So based on that, it will retrieve those information, and it will be sent to the next question as a part of context as well.
Yeah, for larger, I think, yeah, for
Yeah, that's where
dealing with
here
larger
I'm
data.
not saying
Yeah.
like n number. It's based on that because system if I like there is 100 sessions is happened, 100 queries it's sending that again there is a token limit will be comes here. So that's where we're going to take the n number like a last 5 or last 10 based on the business use case. We are going to decide like in the business logic which I wanted to say.
Yeah, there are questions on banking projects. Yes, we do explain banking use cases as well, maybe in next upcoming classes or over the regular classes. Yeah, Krishna, you can reach me about that question. I will help you on the architecture. What tool is being used to extract information from the PDFs?
There are multiple tools like if in terms of scanned document where you have the PyPDF packages and the pillow OpenCV packages. If it is in a like in a other packages also where we can go with that, but it's all about like in a whether the package is also suitable for the the we it is like what kind of the license is there, MIT based license or not. We have to choose. PyPDF 2 will be the ideal the package which can be utilized for to reading the PDF documents.
No, okay, thank you, Master.
Yeah,
Yeah,
and
I think we are done for today. And yeah, just to let you all know that there are questions on enrollment. So, I mean, if you are seriously interested, use that enrollment form and fill that. And we will have one-to-one call on Zoom and we clarify all your questions. And we have projects in GitHub across the domains. There are like 40 plus projects we designed and we'll provide the access. And we have conducted 400 plus hours in last 8 months. And we'll give you, if you are really interested, try to register as soon as possible so that we will give you pre-recorded sessions access. You can listen and join live classes from November 1st. So anything related to fee or enrollment or any course plan execution, we have everything recorded sessions. will provide you, and we'll also explain you one-to-one call over the Zoom. You can also meet me in Alpharetta, Atlanta, if somebody is nearby, and join these classes. So our office is back to Spices Hut, Parkwood Circle, nearby Publix. You can come and join, meet in our office as well. So I will also available in the office tomorrow, 9 a.m. to 2 p.m. EST, to conduct these demos and to clarify, customer questions as well. Yeah, coming to India people, the classes will be 4 days in a week, right? So Thursday, Friday, Saturday, Sunday. Thursday will be 9:30 p.m. EST to 10:30 p.m. EST, which is 7 a.m. IST to 8 a.m. IST. Saturday, Sunday, it will be kind of for EST people, it will be morning class 10:30 to 12:30, and Sunday again 10:30 to 12:30. It's 1.5 hour class and 30 minutes, queries and sessions. So in a week, we are trying to conduct 5 to 6 hours, and we will like give 100 plus live classes, and we explain 10 plus project over the classes, and for the remaining project, we will give access with project documentation, with code snippets and all. We can clone it and practice. Okay. And we also help you on job placement and other services as well. So try to subscribe to YouTube, because whatever the sessions we conduct here, we record and upload, so you can directly get it from YouTube, because it is difficult to share each and every resource. Okay, so join through email. You will get one email before 24 hour, one email 1 hour before for the reminder. Automatically, you will get reminder email 1 hour before in your email. So join through the email. There are people confusing how to join this demos. Tomorrow we have one more project, detailed project, will explain by one of the other senior data scientist, Ganesh Atmakori. So please join for his class as well. Next week we have 4 hours on no code tools. If someone from no code tools background, yeah, they can join and listen. So we'll send that schedule as well. Yeah, you can feel free to exit if you don't have any questions. If you have questions, you can raise your hand. We will unmute and you can clarify your questions.
Kodanrao, I have one question. Can I ask it?
Yeah, go ahead, Vamsi.
Yeah, so Venkatesh, like in this second project, right? The agent can take a decisions. So shall we add a human in the loop there, like, so that so we should not get any hallucination or approvals anything. So human can take a decision for approval or not. Is it possible there?
No, I think human can be involved in anywhere.
But I don't see
Can-
that human in the loop there. So
Yeah, I
as per
think
my
honestly,
understanding.
I can arrange a separate, or maybe you can join tomorrow. So I'll try
Okay,
to clarify your question tomorrow as well. Another,
sure, sure.
another matter. Okay.
Yeah, thank you. Yeah.
Yeah. Thank you all. Happy weekend, everyone. Thank you.